Did anybody follow the development of real-time shared editing? Anybody know what that is? Okay, that is very unfortunate, but very fortunate that you're here now. So what I did just before flying to Mountain View, that was last week in Germany, I did a screencast of the new real-time shared editing facility that comes with Ganymede. And some of you might know Neil Bartlett, who is another fairly well-known Eclipse committer. He Twittered me this morning and said, hey, you and your org are famous. And then, of course, he asked me about a bug that is in real-time shared editing and supposed to be removed. And you and your org refers to that screencast. So if you haven't seen the screencast, then I will just do another live demo and we'll show you, well, something similar with another hint at World of Warcraft or something. Because in the very first screencast, I implemented an org class instead of a person class, you know, the standard boring example. So Scott, Lewis, and I are here. Scott is the project lead on the Eclipse communication framework, of which I am a committer on. And I think we should just get started with real-time shared editing, the demo. And after the demo, I will tell you a little bit about the algorithms behind it, why it's so cool, and what future steps we're actually thinking about. So, Scott, are you signed in into your XMPP account?
Yep, all logged in.
All right, you're logged in. I will log into. This is an XMPP server standing in Ottawa, right? OK. So, all right, Scott, you're the only one on the server. And what I'm going to do now is I'm going to invite Scott to a shared editing session. And both of us are going to flesh out this same class. So let's invite Scott.
OK, got the invitation.
You got an invitation? OK, let's check whether Scott is just saying so or hi, or he is here. All right. He's in the same class. We're editing the same document. And you know what? Most certainly our edits are crossing on the wire. Conflicts are arising all the time when we edit at the same time. But still, the document is staying consistent, being consistent. So, Scott, what should we do? I'll just implement two fields, and you can flesh out that equals method. I will do a name field.
OK, and I'll use the name to complete the equals.
Yeah, for instance. Let's call this name. And I'll do another string, and we'll call that, well, I think Tauren have tribes, but you probably wouldn't care if you don't play World of Warcraft or never heard of it. OK, and while Scott fleshes out that one, I could do something else that makes sense, like, for instance, implement a toString method for this class. So, let me think. Let's return this dot name and this dot. Did you initialize both of those? Oh, we don't have a constructor yet.
I'll put it in.
OK, that's cool. And what else? OK, this is basically how it works like. You can edit the same document at the same time without getting alphabet soup, or without getting errors everywhere. And it might look trivial. It's not. And I will introduce you to the black magic that is shared editing. So let me just. OK, thank you, Scott.
Sure.
Where is my presentation? So that was the really short live demo. I will give you a link to these slides. And the slides contain links to even more material and to the screencast, which runs like for 8 minutes and provides more detail on how to use real-time shared editing within Eclipse. So this talk is about collaborative coding. And if I stay within my time limits, then Scott might even say something about general team tooling. And he might say something about the Eclipse communication framework, not just being about tools, but also about APIs, actually mainly about APIs. And well, if I just use up all the time, then you won't hear anything about APIs. All right. So collaborative coding in Eclipse communication framework lingo is real-time shared editing with Cola. And Cola is the synchronization engine that I wrote. I started out as a Google Summer of Code 2006 student, did an internship with Google, and that's how it all came about. So that's the agenda. I'll talk a little bit, or very briefly, about my motivation for doing this. I'll give you a conceptual overview about shared editing sessions, just so that we have a common basis. I'll introduce you to the challenges, which is just a better word for problems that arise with shared editing. And then we'll explore the solutions. I'll introduce you to the future, not yours, but of shared editing. And well, I hope that after the talk, you leave and are all happy and all fired up to try out shared editing yourself. So I wanted to enable pair programming. I was introduced to pair programming by a couple of friends of mine who did that very strictly. And at first I was going like, okay, interesting, but hey, come on, share a single keyboard, you sit at the same desk all the time. I don't know whether I like that. So people who really slavishly follow Kent Beck's pair programming, they probably won't like this and go like, okay, no, you really have to have that single keyboard. I like having different machines, and actually that enables you to do even more. Another thing is you can do live code review with this, of course. Google has a very, very nice tool, internal tool, which has become public, made even public by the creator, by Guido van Rossum, the creator of Python. It's called Mondrian. And now they have an open source version, which has been released. It's called Rietveld, and there is a review board. These are all, let me call them asynchronous review tools, reviewing tools. With this, you could, of course, do live code reviews. Using shared editing, real-time shared editing, you can help tutor, mentor people, or you might have somebody who knows something better than you, who's a domain expert, or with all the multi-threading coding going on in many teams, you might have a single or two people on the team who know about Java util.concurrent, and well, why not invite them and have them check your code or just code together? It's actually the best way to learn, I think. There's a lot of people who say, hey, examples are the best way. I think if you have somebody who can teach you, it's even better. So obviously, real-time shared editing this way is independent of geographic restrictions, which is especially important for open source teams like us, for instance. I mean, Scott, how often have we met before, like once in person?
Person to person once before.
Right. And we've been working for 2 years, together. So this is a tool that will help you with things in team structures like that. It enables you, or is resilient to location limitations. That means if you're in an open plan office, or if you're just sitting in an office with like 4 or 5 people, pair programming can become a bitch. Because you're loud, you're talking all the time, and people will not like this. So the ultimate goal, summarized, making coding more social, effective, and fun. And you know what? Might sound utopian, but this might not be the right tool in any case. If you have to be totally concentrated, sitting and trying to solve an algorithmic problem, actually, then you shouldn't have your IDE fired up. You should use pen and paper, I think. But still, with many things like, wiring APIs together or learning stuff, this is actually a good tool, is my personal experience. So what we've showed you just now is 2 participants working on the same document, which currently can be a text file, a Java source code file, anything that uses the Eclipse editor infrastructure. These 2 people can work on, or actually are located and working on different machines, and their respective updates to the document are sent over the network. What the synchronizer takes care of, Cola takes care of, is that you, in the end, have a consistent document state. Now, you might say, okay, I'm okay, I'm trying to be diplomatic here, but okay, let's change this. I'm so bright, I'm so smart, Mustafa, you can have a consistent document state if I just, always send the full document over and just overwrite all the changes the other person has done while my document was traveling. Right, because at the end, you will again have the same document, just you won't be intention preserving. Because what you want to have is the changes I did to my local document while changes were on their way to me, I want them to be preserved, vice versa for the other editor. And that is what Cola does. So let's have a look at this conflict-free ideal of a shared editing session. I'm just introducing you to the type of diagram I will use throughout the talk. So Anna and Zoe are 2 software engineering hacker ladies, and they start out editing on the initial consistent document state. That was what you saw in the example as public class Torrent. So just imagine this green bar being, a line of text in a source file. What happens now is Anna makes an insertion at index position A in the document. The insertion gets incorporated into her local document, sent over the network, reaches Zoe and at Zoe, again, gets updated and integrated into the document. No problems so far. Zoe does an insertion at the beginning of the document, index position 0, incorporates the change gets sent over the network, lands at Anna, and again, the document is updated. Now you will say, hey, Mustafa, I don't think I need this synchronizer. Yes, you do. This is the totally and absolutely, well, the most optimistic example you could probably have. So just reviewing what I showed you, we had the same document state, we had some editing, and in the end, we ended up with the same document state. Consistent documents, intention-preserving changes, because Anna wanted to make a change somewhere in the middle of the green section, and Zoe wanted to make a change somewhere, or not somewhere, at the beginning of the document. Both these changes ended up at their respective positions. So again, recapping real fast, no conflicts because Anna generated a change on the common document state that also Zoe had, sends it to Zoe. Zoe updates the unmodified local document with the incoming change. Zoe generates a change herself on this same document that they both have now. The change gets sent to Anna. Anna updates her common document state now, and we're all set and all happy because we have strictly sequential execution. This is ideal, but very, very unrealistic, especially when you code at the same time. So one of the challenges that you run into when implementing, realizing something like this is that, reviewing Anna inserts something at index position A, the change gets sent over, the change is traveling on the network. While the change is traveling, Anna does another update to our local document, inserts something at index position 0, gets incorporated. But what if this packet now travels much faster than the packet that was sent before? So that's one of the problems you can run into. What happens is Zoe gets this first change, the second change that Anna made, that's the insertion at the document beginning. Then the initially first change arrives also at Zoe, but gets inserted at the wrong position. And that is because this change moved all the index positions that insertion A expected further to the right. Well, of course, this old, this insertion at index position A that was generated on an old document state does not know any of this and still inserts at index position A where actually it should have been moved further. So this is, let me say, fairly easy to solve if you just briefly think about it. In-order message sending and reception has been solved by other people, by network protocols. So you just use TCP. TCP takes care of sending stuff in order and receiving stuff in order. Or you can make life even easier, build on an application level protocols that builds itself, again, relies on TCP. So, and if you're really, really smart, you use the Eclipse communication framework because that provides for an abstraction and you're absolutely free to transparently change the provider, the communication application level provider that you use for your shared editing session. For instance, you could use XMPP to have encryption. You could use Skype for the same type of communication. So another challenge that is not as easily resolved is, first of all, one of the requirements we have with this is we want text editors to be responsive. That's what we've been used to forever, right? I mean, what we have here is concurrent edits to a shared resource, which is the document. Now just imagine, well, doing strict locking on the document would never work. I mean, if you want to type something but still have to wait for the negotiation happening to the remote side and then freeing up your document again, nobody's going to use that. And actually, I doubt that it's usable for interactive text editing sessions. So local changes need to be applied immediately. Another problem, network latency. So messages will cross on the wire when you work like this. And when you immediately apply local changes to your local document state and communicate over the network, which again introduces slowdowns, then you have an incredibly high probability for conflicts, for messages just crossing on the wire. And let's have a closer look at such a cross on the wire conflict. Anna, again, inserts something at index position A, communicates the change. At the same time that Anna generates this insertion at index position A, Zoe inserts something at the beginning of the document she has, incorporates it to her local document, That change gets communicated over the wire, ends up at Anna, and let's review this. Is this intention preserving? Anna wanted to have something, Zoe wanted something at the beginning of the document. Okay, it lands there. That's nice. Anna wanted something in the middle of the green section. That's also nice. Okay, that very much looks intention preserving. It actually is. But what happens here? Again, same type of problem as we saw before. We have an operation that arrives at Zoe's site, which does not know anything about this insertion at 0, which did a change, did an update on the whole document that affected index positions. That affected index positions that insertion A actually is dependent on, since they happened at a lower index position. So what to do? How to resolve problems like this? There is a mechanism which I've dubbed, which actually others before me have dubbed operational transformations. And it's supposed to take care of issues such as this. When you have operations, a locally applied operation, and an incoming remote operation, which originate from the same document state. That means the documents don't diverge by more than one operation. Then you can apply the operational transformation on the incoming operation in order to yield another transformed version of the remote operation that you can apply directly to your local document. That's what this slide summarizes and also says. So first of all, we have to think about how do we determine that these two different operations don't divert by more than, or actually come from the same document state. That's actually fairly easy. You stamp each locally generated operation prior to sending it out with a counter. Your local document manages two counters. It's locally applied operations and it's remotely or received remote operations. And actually, these two simple counters are enough to communicate state, which is good because it's simple. It saves you from introducing bugs yourself when you realize stuff like this. So local operation count, remote operation count, these are enough to communicate state.
Is that true for more than binary?
Yes, it is. It is a very good question. I would actually ask you all to save your questions to the end. But no worries. I didn't say that. And it is enough because when you extend this case, I mean, the first realization or incarnation of COLA just takes care of the two-way case. But you can actually do a virtual two-way extended to an n-way. And it's you have a hub instance, and then all the others think that they're engaged in a two-way communication. And the hub makes sure that changes coming in get replicated to everybody else. So everybody thinks it's still two-way. All right, but that's a topic of its own. And I'm not going to cover this in detail in this talk since this is all two-way. All right, so we compare the counters on incoming remote operations with the conflicting already applied local operation. Then we use the COLA operational transformation. We input the conflicting incoming remote op, the already applied local op. We get the updated remote operation, and that is ready for application at our local document. So, and since this is all very abstract, when I just tell you this, let's have a look at the diagram that visualizes this. Again, Anna's edit, insertion. Same time, Zoe does another insertion. Cross on the wire happens again. And now we have this, I've dubbed this co-opt, which just means COLA operational transform. Actually, it's not even called that in the code anymore, but abbreviation. So again, what is supposed to go into this? What is supposed to be transformed? Well, it's the incoming remote operation, and it's the locally conflicting operation. And what are we supposed to get here? What is this operational transform supposed to yield here? Well, fairly easy. We saw this before. We knew that when you insert at a lower index position than the conflicting change, then you won't have to update anything. That's OK, since this insertion did not, in any case, move those indices. All right, so that's exactly what we do. No update necessary. Everything's fine here. So what happens here? We have another operational transform. Here, the remote operation is Anna's operation. Zoe's operation is the local operation. And now let's think about this. What should happen? Insertion at index position A is what we wanted. Operation is coming in, but we have moved the indices by a length of purple operation that Zoe generated. So that's probably the next index, right? So we should have insertion A plus L, where L stands for the length of the purple operation. And when we do things like this, then voila, we have a consistent document state and we have intention preservation. So this is a little pseudocode because what I showed you is, a very simple case. One of the first of all, it's an insertion versus an insertion. It's not an insertion versus a deletion. It's not a deletion versus an insertion. It's not two deletions against each other, because all of these cases are more complicated than this is. And once you've figured out what operations you're comparing against, you still have to see where the indices are and decide how to update those indices. And what we did is, we had these, either you have a local op is at a lower index. In that case, you have to move the remote op to a higher index. If the local op is at a higher index, you don't have to do anything to apply the remote operation locally. So what this gives, though, is we have a combinatorial explosion. We have to, when you implement, some kind of real-time editing mechanism of your own, because Cola right now is text editing, as I said, but it will be possible to, we will abstract an API out of this. It will be possible for you to, use this model of optimistic concurrency control. Optimistic because you first apply stuff and then you worry later, to your own modeling and real-time shared editing cases and applications, like, for instance, building graphs or UML diagrams. And I say combinatorial explosion because you have to determine atomic operations, like, for instance, deletions and insertions. Eclipse, the whole editing or document update mechanism, actually has another notion of a replacement. That would be a third operation. Now, when we think about this, all of these atomic operations, they have to be somehow, you have to define proper transformations for these. So if you have two atomic operations, that means you have four cases. Right? You have two possibilities, basic combinatorics, two possibilities for the first operation, two for the second. If you have three, then it's 3 squared and it is 9. And it gets worse after that. So the fewer atomic operations you settle on, the better for you. And model compound operations such as replacements as, if you can, other atomic operations, like, for instance, insertions and deletions. And a replacement, in the case of Cola, I've realized as a deletion followed by an insertion, and that just works wonderful. All right, so this is just giving some asymptotic notation so that it looks all more serious, but it's actually not really hard. So the cases we have to think about is we have a number of atomic operations square. I explained why, and that's still O n square, no big problem there. Then I showed you the pseudocode with the indice checks, with the index checks. That's always 3 for text editing, so it's a constant. It doesn't change anything actually about the complexity. And now comes the good part, good or bad, depending on your viewpoint. For me, it was bad because I was implementing stuff, realizing this, right, writing the code. And this is not a runtime problem. This is an implementation problem. You will just, your code will be terribly bloated if you come up with 50 atomic operations. If you just come up with 2, you don't have to cover that many cases, and things will work perfectly. And thank God it's not a runtime problem, because just imagine having n-square complexity that every professor will tell you, and your boss too, is very, very bad for you, the company, and the safety of your job, I guess. So, okay, it's linear complexity, by the way, so it doesn't hurt really at runtime. So the fewer atomic operations, the better. Now we have another case. And this case is fairly interesting. This case is the one case that I did limit for my talk and distilled a little just to convey the basic idea and the basic solution. We've realized that, or I've told you that that operational transformations are defined on operations that have been generated on documents that did not divert by more than a single operation. Now, what do you do if you've actually applied 5 operations, a number of operations on your local document, and the remote operation on your way to you does not know anything about these changes that happened while it was traveling? You have to have some kind of mechanism, some kind of resolution for that type of problem. So this is recapping what I just said. We have the generation of multiple local changes while the remote operation is still traveling. So upon arrival of that remote operation, the local dock has not just changed by a single operation, but by a whole slew of operations. So the precondition for operational transformations is not met anymore. Let's have a look at that. What does that look like? We have an insertion that Anna makes. Anna likes index position A, I could tell. So she inserts stuff again. Zoe does the same. And now Anna's change, of course, gets communicated, gets operational, or has that operational transformation we talked about. And this works, actually. We've talked about this. This is easy to do, divergence by a single operation. You can apply this, transform this, and apply this directly, and everything is fine. Anna does something else before she even receives that insertion at index position Z. She does an insertion at a lower position V, incorporates that change, communicates that change. When that change at some point arrives at Zoe's local document, still, the only operation that insertion V does not know of that Zoe generated is still the single insertion at index position Z. We can again apply an operational transformation and can apply this. And it's all intention preserving. We have insertion A at the right position, insertion at index position V, and insertion Z stays at the same place. But what happened to Zoe's insertion Z on its way to Anna? Well, it traveled really, really long. And it arrives at Anna's local document after Anna has executed 2 local operations. Can we apply an operational transformation? Unfortunately, no, we cannot. So what are we supposed to do? Questions so far, by the way? Did I lose somebody on the way? No. OK. All right. So let's have a look at the resolution, because the resolution is actually not that hard. It just takes a little thinking about it. So we, again, execute an operational transformation. And we do that as we did before with insertion Z and insertion A. This will yield a new transformed operation at an updated index position. And we call this purple star, insertion at index position X star. And where X is the position Z where purple was supposed to go to, plus obviously the length of A. And now we'll think about, can we apply that purple star operation directly to our local document state? And the answer is, unfortunately, no, we cannot, because there's insertion V, and that again moved index positions. So what to do now? Well, we're being bright. We just use purple star for the next operational transformation and transform this before applying it locally against the other operation it's conflicting with, and that yields purple 2 star. And purple 2 star gets another update index, which is Y, and Y, again, is the updated index from before X plus the length of the gray operation, insertion at index position V. And now that we have this, we can actually execute the remote operation on our local document state and get consistent documents once more and intention preservation. So now I will just quickly recap and tell you about additional details that I've omitted for this talk, because I thought time would be running out much, much faster. Time did not run out as fast as I thought. But again, introducing these details would just blow up the talk. As I said, I will give you pointers to more documentation. And if you're interested in this, I'd suggest you have a look at that. So what you have to do, actually, in order to be able to do these operational transformations over several locally applied operations that are conflicting, is you have to manage a local queue of unacknowledged operations, obviously. You have to have them somewhere. You have to know which operations to have not been received by the other editor, by Zoe in our examples, in order to know what to transform against. So you have to add local operations as you apply them to your local document, to your queue, and so that the queue does not, at some point run, or your machine does not run out of memory. You have to remove these local operations, and you have to remove them when you see via the state of operations communicated from Zoe that the operations in the queue have been implicitly acknowledged. Like, for instance, if Zoe sends you another operation and that has like a counter of Zoe's insertion has a remote operation counter, that's the operations she received. Oh, God. this would give a sudden end to our presentation. But we saved it. Yeah, I got it. So where was I? Yeah, if the counter says, OK, I have received 5 operations from Anna, and you get that operation and see, hey, my local queue, the most recent local operation I have in my local queue has also a local counter of 5, then you know, hey, 5 and 5 equals, so that remote operation knows about my local operation state, and you can empty the queue. So that was that. Another issue that I ran into, see, I've dealt with these algorithms in 2006. Then I've done a lot of other stuff for like 1.5 years. And just for Ganymede, I came back to this and thought, OK, it would be a nice feature to have. Let's finish this. Let's update this, make it Ganymede ready. And I forgot about this essential part of the algorithm, which meant that 30 hours before the code freeze, before the Ganymede code freeze, you had me hacking 30 hours. And Scott knows this because he slept during that time and then woke up. And then we did test sessions and everything. So I totally forgot about that you have to update the operations in your local queue of your local operations as you transform them against remote incoming operations. So me saying this like this does not have to ring a bell and not have to, not be very, very clear. But again, if I would explain this, it would just, double the time probably. But if you ever think about implementing stuff like this, read the scientific papers once more. And if you do if you do your own version of COLA synchronization, then keep this in mind, bear this in mind. There is this tricky detail, don't forget about it. It's the virtual update of queued up local operations. And I call it virtual because you update them in the queue, but you actually don't apply those changes to your local document anymore.
Mustafa, you forgot to say, read the scientific paper and then call the project lead too.
Yeah, call him too. You mean the project lead?
Yeah.
On the papers? You really want to have the calls? All right, so then it helps to introduce a notion of state space graph, which you can do. Then you see where how to traverse all the possible document states and everything. But again, that you need once you start fiddling around with the queue. And we're not doing this. So what should the future bring? And this is actually where you come in. Try out the feature. Please, please, please try it out. I think most of you, I guess, will like this. And there will be things, especially usability issues, since if you do a 30-hour hacking session, usability is the very first thing that you save up on as a developer. So find these issues and just either drop me an email, comment on my blog, send us an email to the ECF dev mailing list, and either report bugs or submit feature requests. One thing that is obvious that we should do at some point is have more than 2 session participants. Another thing is right now, we're sharing single documents. Would be cool if you could share your whole document. And the thing is actually, COLA would not even have to be changed for this. It's all the surroundings, all the session management, and all the sharing and sending over of the other files that needs to be changed. Because what you would have is you would have a COLA synchronizer for each of these editors. So that's something that would work now. So that's something that I, on the one hand, predict is not going to take long. On the other hand, I'm still a college student. I have finals coming up. So yeah, you might have to wait until August. Oh, college student in Germany. That's why it will take a while. So, and then, yeah, another thing we will have to do, or thinking about doing, and that's, I've referred to this a couple of times during this talk, is, extract an API. Make it possible for others to implement other editors. Not just text, but also graphics or graphs. Yeah, that's the bright diagrams, anyone? Then deeper integration with Eclipse. That's something I really, really want. That's something we will have to talk about with the UI and platform people on the other teams. Deeper integration means, would be great if you could see where the other editor is, see multiple cursors. That's great. Or see highlightings. If I want to point out a certain region in the code, I would very much love to be able to highlight that, and that highlight getting communicated and marked at the remote site. So yeah, Scott can talk a little more about this, but then again, I did manage to fill up time.
Why don't we have questions?
Before we have questions, that's the resources. So what I suggest is, OK, drop by my blog, drop by Scott's blog. You can have a look at the ECF pages. And then there's this wonderful screencast. Well, actually, it's very simple. it just shows, an 8-minute editing session that I did with my hacking pal, Tom, in Germany before leaving for Mountain View 3 days ago. And that's the exciting thing. So apparently we've struck a nerve with this project because I just uploaded this on Vimeo and it got more than 6,000 views in 6 days. I mean, it doesn't even feature cats or cute hedgehogs or anything. It's really just me. I mean, crazy, and shared editing. All right, so much for my talk. Hope you all enjoyed it and hope you're all fired up to try this. Yeah, and questions.
Actually, got two.
Yeah, go ahead.
Questions. What makes up an operation? You send something over every keystroke, or you collect them and then send over 20 of them?
OK, I'm just repeating this for the mic and for the recording. So what makes up an operation? Is it single keystrokes? Is it something else? Actually, it is every change to the document. So, and it is a very good question, better than you might suppose, because for my Google Summer of Code project, I just implemented this to work on single keystrokes, which is not that cool when you copy and paste stuff, because that totally screws up your whole state model. Well, that works now. You can copy and paste code, you can delete single characters, you can delete whole sections of code, all works. So any change to the document gets wrapped up into an Cola update message and gets stamped with local and remote operations counters and sent over the wire.
The second question is, how does it interact with the team environment or check out files from the source control?
Mm-hmm.
Since you have the same file on two systems, will it check it out on both sides? Or?
So,
Sorry, go ahead.
OK, all I wanted to say is right now it's not integrated with anything beyond this. The focus for this effort was, get the synchronization right. See, I wrote an internal, when I did my internship at Google, which actually also has been open sourced, Perforce Eclipse plugin. So that's a team repository provider, and I would suppose that you need to, have to integrate these somehow. So, but it's not integrated right now. Team repository providers and this. Scott, you wanted to say something?
Right. I mean, that's an area where we definitely are planning work. We've already got sort of enhancement requests, basically integrate, version control, right? Whatever provider, Subversion, CVS, whatever, with basically the team API. And we can do that pretty easily because actually we do have sort of other code that allows people to sort of remotely tell someone to, do an update.
Oh, Scott, now you have to say it all again.
You guys could hear me, couldn't you? No? Yeah. Ian's nodding yes. So I'll just leave it at that. But yeah, so integration with version control is definitely high on our list. We're getting to the point now where we do these things separately, basically, and we'll now be sort of putting them together.
But conceptually, how does it work? Should both users have it checked out, and when one checks it in, the other automatically is checked in?
I think that's a really good use case. It probably won't be the only one that we deal with. So, I mean, that's, I'm sure, a frequent one. We might have one where it, if you don't have both parties have it checked out already, one party is asked to check it out rather than actually sending the state across, like we did here. And, maybe even do something like, merge if necessary. Basically to guarantee that they have a consistent initial state.
I'm assuming it doesn't because it seems kind of complicated, but does it do any integration with the internal Eclipse versioning stuff so that you can go back or so that it can tell who added what and things like that?
OK, so the question is, does it have or feature any kind of integration with the Eclipse versioning mechanisms? And it doesn't. As I said, right now, all it does is exactly what I presented. It's the synchronization and making sure your document and editing session doesn't blow up. But these are all good ideas. And I would really, really suggest, the simplest thing is just drop me an email. I will make sure it gets at least into the Bugzilla if it gets fixed.
Or just open an enhancement request on the project.
Yeah, so
I know
it would be
people are not so
perfect,
used to that,
yeah.
but that's also a good way. We'll do it for you if necessary.
Yeah.
That's why.
Go ahead, Kelly.
What is it that you have to do refactoring, say, like a rename of a method using the Eclipse refactoring?
So the thing is, if you do a rename, which is right now limited to the to one file, then obviously these would be document change events. Well, I would hope, because if they are document change events, I feed all document change events into the Cola synchronizer. So anything that is a document change event or triggers one goes into the synchronizer and gets spit out correctly, which means gets communicated over the wire, gets handled within the queue. Now, one thing we've come across is that, for instance, certain changes like the syntax completion and stuff like that apparently does not seem to either trigger a document change event, or there is really some other type of bug. And I didn't have time for looking into this, but that's been something people have been asking me after the screencast, because I don't use, syntax completion and the auto import functionality, because that just does not use the synchronization mechanism. So I will have to make sure that I catch those and also feed them into the synchronizer.
Anyway, those are also document changes.
Excuse me?
Even those syntax, this thing completion, the document changes, right?
I hope they are document change events. Do they fire document change events?
They do ultimately, yeah. I mean, generally. I mean, unless there's a bug like Mustafa said. But
yeah.
I mean, one thing to mention though is that, for things like metadata, like say markers, I mean, we can add, and this is another area where we're going into, we can add kind of the replication of metadata, and in fact other kinds of kind of characteristics to a model. Like say, you want to replicate the entire sort of abstract syntax tree, or say a model which includes sort of dependencies between classes, rather than just the source code for a single class. So we're expanding kind of the notion of what the document consists of to more toward a general model. And then we can apply the same sort of notions of synchronization to those more complicated models. That is defining a set of operations that are appropriate for that model, and then transforming them as they change to synchronize the replications for that model.
Right, so, if a single term sticks with you after this talk, it should be optimistic concurrency control, which means you have a shared resource, you update this, one of the changers does, and then you worry about fixes. There was another question. Let me first have you, sir.
If your counters match,
excuse me?
If the counters match on both ends, are the documents always guaranteed to be in a system state?
Yeah.
Do you do any verification of that, or do you just?
Oh, you have to. I mean, I don't.
Depend on the algorithm too, that it's always going to be correct.
The algorithm is algorithmically proven right, and you can do stuff like that. But of course, it's one line of code to check the last incoming ops and.
So you might miss the last one.
Yeah, but there's another thing. What you have to consider is, let's imagine the two of us coding, and you just make 3 changes, and after that I do 100. So then you always get updates from me. How would I know that you have sent something that I didn't receive or something like that? So what you want to make sure is that the algorithm is right, and that the algorithm deals with everything that that you receive, and that it ultimately yields the correct results.
Right, and then also the ECF kind of abstraction layer also guarantees things like reliable delivery, or failure detection in the case of sort of remote process failure, so that you can recover back to sort of a known good state.
First there, and after that, it's your turn. Yeah.
I have a bit of a more conceptual question now. It occurred to me when you were talking about integrating with team providers. By the way, I wish you the best of luck with that, because you're going to need it. My question, the thing is, a lot of times, since I've been trying to work remotely and also work with other people, a lot of times it'd be easier. I don't really want them to see my workspaces as so much as I would like to shadow theirs. No, it's theirs is like the master, so to speak, that they see the any changes and stuff gets in there, and then obviously if you have any team problems, it better be configured correctly over there. Is there any thought been put to that, or?
I mean, the answer is yes.
Repeat the question first.
Well, the question was, has there been any thought given to kind of replicating someone else's workspace, it sounds like, basically to see what the state of their workspace is. Is that correct? Yeah. So, yeah, absolutely. We sort of are doing work on sort of replicating pieces of the workspace We haven't, I mean, the use cases for that, there are a bunch, right? So say you want to do a review and you sort of want to get all the kind of state of various source files and whatever else happens to be in the workspace for, say, one or several projects, and have that feed into the review. Well, like say a review scenario would dictate kind of certain things about the availability of sort of read versus write access to those resources, and who has access to changing those resources. So we are the APIs that ECF consists of are consistent with kind of supporting those different use cases, and we're sort of exploring which ones are the most valuable given kind of the team support for distributed development. And so we would love to have your input on kind of which ones you find most valuable, and which ones you'd like to see us address first, because we have to sort of make decisions about which ones to focus on and which ones not.
Okay, more questions. You had one?
I just wanted to know, are there any unresolvable conflicts between two different document modifications?
Not with Cola, not with, once we abstract out an API, it's up to you to define the proper operational transformations. So if you forget something, or if something goes wrong with your set of atomic operations and you've forgotten something, or modeled a compound operation, formed it up from the wrong atomic operations, then obviously stuff will go wrong. But with text editing, that's solved by Cola itself in this, exemplary implementation.
So if you both add code at the same place, or?
Yeah, that works. So if we both, work at the same place, or even worse, think of harder cases. Like, let's say you're deleting a patch of text, like character 1 to 10, and I insert stuff at position 7 to 10. So that moves your, the characters you actually intended to delete further in the document. So what's supposed to happen to the deletion, to the incoming deletion to my document, where I actually inserted something in the middle of the section where the deletion is supposed to occur? Well, then you have to split up the deletion. And you have to think about these cases. That's why I said it's very, very important that you have very, very few atomic operations. Otherwise, you will be dealing and implementing for a long time.
Well, and there may be other models, like say a graphical kind of model, where there are situations where something occurs that if you resolved it, it would be very jarring to the user, right? So you may at that point want to say, oh, basically I give up to the user. You need to sort of resolve this conflict somehow. Now, for text, that's not necessary because Cola kind of resolves things in a natural way, but for other model forms, it may be.